Hello, everyone from my side as well. It is my pleasure to introduce you to the new Fluff to Film concept developed by Reifenhäuser, a new technology that I'm sure will boost recycling to the next stage. Before we head into the technology itself, let me give you a quick introduction and raise the awareness of a problem that not only faces plastic industries, but the whole world. The problem of, or the challenge of handling the film scrap. If we have a look at the history of plastic, you can see that within the last 65 years, from 1950 onwards, over 6.3 billion tons of plastic waste have been created, of which only 9% were recycled, 12% were incinerated, and an alarming number of 79% of the plastic scrap ended up in landfills or even worse, in the natural environment. If we continue like that, forecasts are that by 2050, so in less than 30 years, we will end up with over 12 billion tons of plastic waste that will end up in landfills or the natural environment. These are shocking numbers, and luckily, these numbers already caused several initiatives, especially politics and governments all around the world, to start working on campaigns and initiatives to get a more sustainable future. One of the more famous initiatives comes from the European Union, the Circular Economy Strategy Plan that was released by 2018, so it's already 2 years ago, and it demands that by 2030, so in less than 10 years, all plastic packaging should be reusable or recyclable. More than 50% of the worldwide plastic waste should be recycled. Effective waste collection and sorting systems shall be installed, and a consumer awareness shall be increased to avoid litter and ensure that the waste is handled appropriately. So politicians are putting some pressure on the economy and the plastic industry, and you can already see the first results, especially when having a look at the big brand owners. They all start initiating their own sustainability programs, and they are really willing to commit themselves to more sustainable solutions to get a greener future for everyone. Looking at some references, for example, the Danone Group that commits that by 2025, so in less than 5 years, they want to reach 25% of recycled material on average in their plastic packaging, 50% on average for their water and beverage bottles, and 100% of EVM bottles should be come from recycled materials. Another famous example is the Walmart Group that seeks to achieve 100% of recyclable, reusable, or industrially compostable packaging for their private brand packaging within the next 5 years. The target is at least 20% of post-consumer recycled content in the private brand packaging by 2025. And last but not least, the IKEA Group already commits that 98% of their home furnishing materials, including packaging, are made from renewable, recyclable, or recycled materials. So you can see there's a lot of movement on the markets. And of course, we as the Reifenhäuser Group, since we've been pioneering the future and looking for solutions for more economic and sustainable solutions in the plastic world, are proud to present the Fluff to Film process to you today. So to give you a brief idea of how we started or launched the Fluff to Film research and development, we firstly had a look at the state-of-the-art recycling process. If you look how recycling is done in most cases in the industry, you will start with the waste collection, of course. Once the waste, the film scrap is collected, the next process step will usually be a first shredding, then fusing, and finally the pelletizing of the material. Before then, the pelletized polymers can be reprocessed using a conventional blown film line. When analyzing this process flow, we saw that the fusing and pelletizing step not only needs an energy and cost-intensive additional process steps, but also the overall material quality is significantly reduced, since every fusing and melting process shortens the molecular change of the polymers, which overall reduces the film qualities. We thought, what if we could find a solution where we can skip those energy and cost-intensive process steps and instead use the film scrap and shred it to directly refeed it into an extrusion process. And this process is what we call the Fluff to Film process. And on the next slides, I would like to take the time to briefly introduce you to the process in detail, starting with the shredding process at first, the second process step being the conveying of the small film particles called fluff into its final destination, the extrusion part. If we have a closer look at the first process step, the shredding, you will see that for our setup or our system, we went with a very flexible system that not only allows the infeeding of plastic bales or any film scrap using a conveying belt, but we also equipped an unwinding station to our shredder system to be able to directly infeed startup or rejected film rolls from your production to the shredder, where the material is then shredded to small particles in dimension of 16 to 18 millimeters. The next process stage is the conveying of the fluff. And one of the biggest challenges of fluff handling is the very low bulk density of the material. So when shredding the film scrap, you will end up with huge volumes of plastic fluff that comes in with a very low overall weight. And especially when trying to convey or handle the material, you very often face the challenge of film blocking in the process. We compensate this problem by using pedals and swiveling arms in all our silos that we have installed in our conveying system to make sure that the material is in constant movement and no blocking occurs in any stage of the process. For further conveying, we make use of discharged screw conveyors that make sure that we have a constant and proper feeding to the next process stage. And for the piping, we make use of a vacuum suction system that works perfectly fine for the conveying of the fluff to its final destination in the extrusion part. Now, having a look at the extrusion part, this is the heart of the machine, you could say. Firstly, the fluff enters from a storage silo that we use to compensate any interruptions or problems with the shredding part. So if the material feeding in the shredder is interrupted, we have at least a buffer from the storage silo from where we can feed the fluff directly into the extrusion part. The first stage of the extrusion part is the gravimetric dosing silo. So the fluff enters the dosing silo where weighing hoppers are constantly measuring the material to make sure that it's properly fed to the extruder itself. Above the extruder, we make use of a special forced feeder where a conical screw force feeds the material into the extruder itself so that we have no blocking in the feed section. Another thing or another challenge that has to be handled when processing fluff materials. Since we aimed for highest flexibility with our technology, we not only equipped our machine with a gravimetric dosing silo for the fluff, but thanks to a conventional batch dosing system that's additionally equipped to the twin screw extruder, we can not only process 100% of fluff material, we are also good to go with up to 100% of pelletized materials, so either being it virgin materials or recycled pellets, or even better, a combination of both worlds, mixing fluff materials with pelletized materials to reach specific overall quality properties that are demanded for your final film application. The extruder itself, as I just recently mentioned, is not a conventional single screw extruder that is usually used for blown film application. For the fluff to film concept, we use our special EvoFusion twin screw extruder. The twin screw extruder offers superior homogenization rates and a much smoother melting process within the extrusion process, which is really beneficial for recycling applications where you need to really or need to have a much better homogenization of the material mixes that you want to process. Another advantage of the twin screw extruder is the possibility to degassify out of our process. So thanks to the degassing units, we can extract any contamination out of the material like humidity or inks that usually come in with recycled or material scraps. What's also important to mention is that due to the lower pressure buildup in a twin screw extruder where you have two co-rotating screws within one barrel, you need to have a volumetric melt pump to increase the pressure of the melt before it enters the die head. The next process step, same as for any other conventional blown film line, of course, we use a screen filter for our setup as well. for this, for the fluff to film approach, we went with a continuous one with the dual plates to make sure that we have a continuous processing without any interruption. So filter changes can be done without having to stop the machine during the production. And last but not least, in the current setup that we are looking here, it's a monolayer setup. We use our special dual layer die head, where we have a dual flow channels within the die head, where we create an overlapping of two melt flows. And by doing so, we create or increase the overall bubble stability and material quality, since the chance of small holes or gels in the film itself are significantly reduced. Speaking of the monolayer setup, the mono setup was our first development stage, because we wanted to make sure that the fluff to film concept is working perfectly fine in a monolayer setup. Since we mastered this challenge, the future for the fluff to film concept, or our next development stage currently, is to modify the machine going from a monolayer setup to a co-extrusion setup, because we are sure that a co-extrusion setup, for example, a 3-layer setup where we use the twin screw extruder in the center layer to process all the film scraps in the middle of the film structure, and use 2 conventional single screw extruders on the skin layer, will ensure us to furtherly boost the overall film qualities, especially optically, but also mechanical film properties, by using higher quality grades on the skin layers of the resin structure. As I said, we've installed the fluff to film concept in our research and development center here at Reifenhäuser, and we've used the previous months this year, especially during the COVID-19 times where everyone had to be in quarantine. We made intensive testing and trials on the technology. And it is my pleasure to bring to you today our 5 best practices that we've experienced during the previous months. The first example that I would like to bring to you is the reprocessing or recycling of barrier film structures. So we've done intensive testing with material structures, mixtures of polyamide, polyethylene films, where we not only processed pelletized, already recycled or pelletized barrier materials, but we've also done intensive testing with barrier film scraps that we first shredded and then directly reprocessed in the EvoFusion twin screw extruder. And the results from those trials are that we are able to significantly increase the amount of barrier materials in our film structure, while additionally reducing the overall amount of compatibilizer that is needed for our film structures to get good mechanical properties. Another very positive reference or example that I would like to present to you is the processing of heavily printed films. Like you can see on the picture, we've done several or numerous trials with heavily printed films that were up to 100% of printing or ink on the film. And in this case, or especially for printed films, we could see that the benefits of the degassing units are second to none, giving us the chance to degassify any inks out of the film, ending up with much higher and much better film qualities and properties. The third very successful example was the processing of sticky films with an adhesive layer. As you can see, a trusted customer of ours, he submitted in-house waste where he didn't know what to do with the materials. And we are running the film fluff, as you can see it here, directly into the EvoFusion twin screw extruder. And the results of the film, without having to add any process aid or additives, were very surprising and very positive, giving the customer a very efficient and economic way of in-house waste handling. One of the biggest challenges in recycling remains the processing of post-consumer materials. And of course, we at Reifenhäuser wanted to give post-consumer materials a shot as well using our EvoFusion technology. And I think the picture on the left side requires some explanations. We've been submitted materials, post-consumer materials from a customer of ours with problems due to high humidity content and very low overall film qualities of the PCR materials. He sent over this material and said, okay, if I tried to process these materials on my conventional blown film line, and I ended up with huge holes in the film, and I wasn't even able to produce any film out of it. we gave it a shot and tried to ran the material through our Fluff to Film line. And thanks to the better homogenization as well as the venting units in the twin screw extruder, we were able to make a very decent film out of it. Last but not least, we've done numerous trials with post-industrial film scraps that were submitted by customers of ours. And we were able to get the cradle-to-cradle process to its optimum by running the post-industrial fluff directly into the twin screw extruder and making new films out of it. So I think this gives you a rough idea of the technical benefits of the Fluff to Film line or Fluff to Film concept. And on the next slide, I would like to briefly present to you the commercial numbers behind the Fluff to Film concept, because before we even started the research and development on the Fluff to Film concept, we made the business case for ourselves, and we were really surprised by the numbers or the outcome that the Fluff to Film concept has in potential for you. To explain the business case that we made, we took the capacity of the twin screw extruder with roughly 400 kilograms per hour and multiplied it with 8,400 annual production hours, which gives us an annual capacity of 3,360 tons for the material processing. If you, in a second step, compare the market prices for waste materials, so film scrap that you would buy from the market, compared to already pelletized materials, you end up with a price gap of roughly 30 cents per kilogram that you would have to pay on the market for the recycling of the film scraps. And I know, especially depending on where in the world you're discussing those numbers, the numbers shown in this case will always vary depending on where you're buying your material, and especially when you do in-house recycling, the price gap may be even lower. But please feel free to edit this business case with your own numbers to see with what savings you end up in the end. For now, we took this price gap of 30 cents per kilogram and compared the material costs for the state-of-the-art granule to film process, and then to put it against our new Fluff to Film concept, where we save the 30 cents per kilogram by skipping the pelletizing process step. And the numbers that we came up with showed that just the material saving due to the skipping of the pelletizing, we were about to save 1 million euro just for the materials within the first year. So if you consider this for your return on investment calculation, the Fluff to Film machine pays off itself in fastest time. And honestly speaking, we thought these numbers are too good to be true. So there was the point where we said, okay, we now need to really start the development on the Fluff to Film line to make proof to those numbers. And reality is that we now have the machine working, it's proven, and since we've discussed with many trusted customers of ours who entered their own numbers, we've got several confirmations that those numbers seem to be quite accurate, and the saving potential for the Fluff to Film concept is really enormous. Coming to an end, I would like to summarize the overall benefits that the Fluff to Film technology and especially the Evo Fusion twin screw extruder can bring to you. If we have a look at the energy and cost efficiency, I'm sure that right now there's no other extrusion or blown film extrusion solution that is more economic and more efficient in regards of recycling than the Fluff to Film concept. Thanks to the skipping of the pelletizing process step, while increasing the overall amount of cheaper plastic waste materials or fillers. In regards of quality, thanks to the better homogenization capabilities of the twin screw extruder and the possibility of having a degassing unit, we are able to increase the overall qualities. And since we are skipping the pelletizing process step, where we need to fuse the plastic scrap first, we are really cutting the heat history of the material in half, remaining much higher overall quality of the polymers. Last but not least, if we have a look at the handling of the material, it can be said that we really aimed at maximum flexibility so that the Fluff to Film machine will be available from monolayer setups up to 5-layer machine setups soon. The operation of the Evo Fusion machine is as simple as any other Reifenhäuser Evo blown film line, thanks to our very operator-friendly EvoS line control system. And since we are not only equipping our machine with a continuous dosing system for the Fluff, but also equip the machine with a conventional batch dosing units for pelletized materials, we can process either 100% of Fluff, 100% of pelletized materials, or even better, a mixture of both worlds to combine or to reduce the overall material cost to minimum while maintaining the overall film properties at the maximum. And this brings me to the end, and I hope that I received some questions from the audience that I would be happy to answer now.